Hey folks, my name is Andrew Hamill, which you could tell from the name of the YouTube page. I don't have a lot of content on here. In fact, I don't think I have anything other than this first video that I'm posting. And the biggest reason is because I kept wanting to wait until I had something more substantial to show. You know, I've got planning documents and I've got things like this and that that are, ooh, eventually I'll create this type of content and it'll be scripted and it'll be planned and I'll have resources and it's like, I'll do it eventually, but I want to put something on here. I want to have something. And I was thinking about an example, one of my first things that I coded in raylib, and I wanted to rebuild it here. So I use raylib for a lot of my programming. It's a C library, open source. We can actually check it out here once I find my cursor. Here we go. There we go. So it's a C programming library here. I believe there's a GitHub link somewhere, probably at the top. Yeah. So it's a unique OpenGL abstraction layer, full 3D support, animated 3D models. Well, that's not where we're going. We're going to use a 2D example today, and we're going to build a really basic 2D example. So you can see here they've actually got, this is all of the boilerplate you need. It's unique in that there's very little boilerplate needed. So ultimately, there's an initialize window method that you call. I should say function, not method. I'm a C# developer currently, as a professionally, so I'm in the habit of using all the terminology. So with a initialization function, and then ultimately you create a while loop, which acts as your game loop, and we just check against this function, which will return. It'll return true when it's time to close. So we can just put it in a while loop, and then you have a begin and end drawing, which really indicates that we're opening up the buffer, and then you can have a clear background, so you just put in any old color, and you can draw text, you can draw shapes, you can draw sprites. It's very good. It's very simple. So we're going to go ahead and put together a really simple example just to see raylib working, and then we're going to replicate the paper stacking, really just object stacking, create kind of our own little z-index thing, kind of like what we have in Papers, Please, where we can pick things up, move them around. If you've played Papers, Please, or really any Lucas Pope game, you know what I'm talking about. Absolutely love Papers, Please. Obra Dinn. He has a lot of really great game jam games as well. So if you haven't checked out Do Cope, I would say definitely do so. Lots of cool stuff. Eventually we'll get this Playdate release, which I'm really looking forward to. I'm a huge fan of the Playdate. Can't wait to receive it. So very good stuff, very fun stuff indeed. So we're going to be looking after this this aesthetic here. So we have these overlapping objects that can be moved around on the desk. We'll see if we get an actual example. There we go. This is what we're going for here. So if the player was to now try and grab this work pass or this entry permit, it would actually bring it to the front, but everything else would be in the right order. So what I'm imagining is a data structure that wraps an array, and we can ask that data structure to move an element that is within the array to the top. So ultimately what we're going to do today is we're going to create a basic raylib example. We're going to get some objects that we can kind of move around, and then we're going to put those in a list that is managed to keep the order of the elements in the way that we want them to be displayed, basically. So if you've installed raylib, then there is a special version of Notepad++ you can use, which is set up to where if I press F6, I can basically just immediately compile the file that I'm looking at. It will treat that file as a main.c and hopefully spit out an executable and actually run that executable. So to make sure that it's working, we're going to get a really basic, a minimal example of a raylib window opened. So I need a screen width and a screen height, and I'll just call this raylib example. And now, while the window should not close, we'll do a begin drawing and an end drawing. And I'll just keep it with a blank screen. Okay, so that is like a minimal example. Let me just get a main.c. Oh, I totally forgot that I had a example executable that I can show off, kind of demonstrating what we're after here. You can see I can pick all these things up. I can move them around. Maybe we'll throw an outline on them so it's easier to see where they start and begin, because here it's hard to tell that, you know, there's that distinction. And I have it so that just draws a shadow on the one we're carrying, just because I think it looks pretty cool. So this is kind of what we're going for. Just gonna obsessively, that could be like a puzzle game. Look at that. Okay, that's what we're going for. So here's our main file. Now, because it's a .c in the name, Notepad has already identified that I'm using a C source file, but I could always go into language and choose a language. I think ordinarily this list is a lot longer, but I've pruned it to just have C and C++ because those are the only things I would ever do in Notepad++. And I will also say, you know, I am a professional and I would not use Notepad++ just because my projects would typically be a little bit larger and the thousands of lines. And for that reason, I don't think this would be the most powerful thing. But for the purposes of learning raylib, this particular installation that you are actually equipped with is going to support... I'm just going to move this over a little bit so we can actually see that stuff. I think that's important. It's going to be able to autocomplete raylib functions. So if I was to say draw, we're going to see a bunch of things we can do, and that includes drawing a rectangle. And we can see here I need to give a position of X, so we'll do screen width by 2, and actually screen width doesn't exist yet, so maybe just for the sake of, I'll make the width and height actually the same value. So we'll draw it at screen width by 2, screen height by 2, just to give you an example of actually drawing something in raylib. Let's go 100, 100, and we'll just make it blue. I should clarify as well, with those colors, raylib does have a provided cheat sheet, and you can see all of the methods here. If you're not using Notepad++, maybe you're using Vim, or you just really want to browse and see, hey, is this something I would be interested in? Is this going to have the features I'd like? And if we look over here, we've got a list of some built-in colors. So I can just type in blue, and I'll get this color. And I think I actually want sky blue. That sounds a little bit more fun. Let's try sky blue. Okay. So now if I press F6, it'll bring up, this is NPP exec, which is a plugin for Notepad, that Notepad++, that makes it so you can write scripts that you can execute. So if you have, maybe you have a make file, for example, then you can queue it up and actually run it here. So that's what this does. It's all pre-configured. You can make small changes. So for instance, if I was writing a C++ program, instead of calling GCC, I would call G++. But I'm just going to leave it as is because actually this is going to work with what I need. So if I just hit OK, it'll compile, as we can see with this little console here. It's a little bit laggy and strange, so you get these little pop-in and outs. And I'm going to be getting this GeForce experience thing a lot, which is really frustrating, but well, we live with it. So you can see here, ultimately, it's gczo main.exe main C, and then it needs to link to the raylib data. That's where it gets like the little thumbnail, as you can see on the... Oh, you can't really see. But if I open this window, you can see there's a little thumbnail and a bunch of other stuff. So if you're really interested in what it takes to like build a raylib project, then yeah, you can absolutely read into that. Personally, I'm just going to not worry too much about it. I'm going to hit F6. It's going to open the NPP console. And for the most part, I'm going to keep it folded down here fairly tightly because, I mean, generally speaking, I'm going to try and write code that works, but if it doesn't work, I'll get an apt description. So here's my window. I got a square in the middle, but if you've never worked with any kind of graphics interface before, you might be surprised to see that it's not really in the center. Actually, the top left corner is in the center. That's because the origin of the rectangle is the top left, and then size X and Y specifies how far right and down it will go. And of course, the top left corner of the window is actually 0, 0. So those are just some things to keep in mind. So if I wanted this thing to be in the middle, truly, I'd have to take out half from the Y and half from the X. And if I run this now, it'll be dead center. So that's just another little thing to keep in mind. But we will explore that thoroughly as we go. So what would be really nice is if we could have a bunch of little squares like that and just get them showing up on the screen and drawing. So that's actually one of the first things I do. Now, for the sake of this, kind of tutorial, kind of just example. Watch me go through an example. I'll point out things here and there. If you've never used C, you're going to have a lot of questions, and I'll try to explain them, but I also don't want to take too long with this. So my priorities are to get, I have the basic raylib example, so we can scratch that off. I want to get objects that store their position, size, color, and kind of scatter them across the screen so we can get a few of them going. Then I want to make it so I can move them. And ultimately, I want to move those into a structure that actually manages their position for me so that when I pick one up, it is brought to the front of the focus. So we're going to have a list where the position in the list represents its actual Z index, meaning when it is rendered. And we'll be able to sort of have that process basically have a system where the user can just pick squares up, move them around, and in the background, it is shifting around this array. It's not going to be the most efficient thing because we're just going to use an array. And for those of you who are familiar with this kind of idea, basically I'm going to be doing a lot of swaps and a lot of just move operations within the array. And in C, there's not really much of a way to clean that up, short of having some kind of linked list and changing the positions that way. And it still wouldn't be the greatest thing in the world because then we're dynamically allocating memory. In the past, I thought this was the only way to enjoy C, and it's truly the only way to unlock certain features. But at the end of the day, if you just create an array that's larger or about the max size that you expect, it saves a lot of headache and a lot of trouble. And if you just accept those little performance hits, generally speaking, C is lightweight enough that it can afford those little mistakes. And if you're really crazy about performance, you can go deeper. But at that point, I'd recommend using C++ for more complicated things. But I also do really love C, and I'm not going to tell people not to use it because that is a really frustrating pattern that I notice. So one of the things we're going to do to keep this fairly simple is we are going to use multiple files, but we're only going to have one source file. I'm going to have header files, and again, I know this is not ideal, but it's for simplicity's sake. We're making header files to be able to split up the code a little bit, but I'm going to actually put source code into the header files. Ideally, you would have multiple source files, and you would use something like make or CMake to actually do the compilation. And those programs would look at when the last time the source file was updated and the last time that source file was compiled. And if it hasn't been updated, it won't compile it again. And it makes compilation time a little faster. And when you're building a game engine, that's relevant. And when you're building a game, that's relevant. When you're building a small example, the hassle of getting some of that set up might not be worthwhile. And for the purposes of this video, I'm just going to use multiple header files that are local headers, but they're going to contain source code. So not ideal if you're working on a big project or if you're wanting to learn the best way to do some things. I am going to be creating a C course. I've been working on it for a while. And I didn't want to wait to finish that to be able to make some content. I want to practice making these videos first. So anyway, let's get to it. That's enough rattling on here. So I'm going to create an object header file. And what that means, I'm going to make a new tab, and I'm going to start off with something really important, which is the name of the file. Let's be honest. So it's got to be the exact same name that I typed. So here I put object H. I got to make sure this is called object H. It's really small on the recording. I apologize. If you're watching this on a mobile device, I'm going to keep the code nice and big so that you can read it. But some things are going to be kind of hard to see, but only things like tabs. And, I don't want to blow up my Windows scaling values because then I'm sitting in a monitor. That's, it'll burn my eyelids or my eyeballs, really. So the first thing you want with a new header file is an include guard, which what this really does for us is, there we go. What this will do for us is it allows us to make sure that all the code that we put in this file never gets included twice. So when I say include here, it's going to effectively take everything that's in this file and copy paste it. But when it copy pastes, it's going to look at this and it's going to say, okay, this says if not defined, object H. So if there is no object H, it's going to define object H, and then I'm going to have all my code in here. Code here. And then the next time I say include H, it's going to say if not defined, but guess what? It's already defined, so it won't. Oh. My wake word on my Echo Dot is computer. So it's going to go ahead and see, you know what? This is already defined. It's not going to paste the code, and you're not going to get any duplication, because what you will know if you know much of programming is if I have two things called screen width and I try and compile this, oh, wait, what? Oh, I see. Let's try that. It's a little different because they're in a global scope. But as you can see here, I am trying to redefine screen width. You can't have the same variable defined twice. So if you were able to paste these header files in more than once, you would get a lot of errors. So having that include guard just protects us from that. So in C, if we want to have an object, we really want to have our own data type that contains data types. That's called a struct. So if I write struct object, then I can give the object some things. So I can say it has a color. I can say it has a vector2, and I'm not getting any autocomplete because I need to also include raylib in this file. Now don't worry, this include guarded thing, I'm including raylib in both places, but raylib also has an include guard. all header files should have something like this. So I can include this as many times. I can even do this, and it will be fine, but generally you want to avoid that. So I want a vector2. Oh, do I have to save? Oh wow, I just don't get autocomplete outside of main.c. Oh, that's okay. So the objects have a position, and they're going to have a size, and they have a color. Cool. So that's it. Now, to create an object, right now, if I wanted to create an object in this file, I'd have to say struct object O, and then I'd have to go through and say position is something, size is something, and really what would be nice is if I could just call a function and have it return an object. So it's kind of like a constructor if you've ever used an object-oriented language, except it's really just a function that has a return type of object. Now, something else that's a pain in the ass is I have to write struct object every time. I can't just write object. This is because, well, I don't really know. This is just the way that they decided to make it in C. But we can get around this by actually giving struct object a nickname. So this is my way of assigning a nickname. And down here, I can just write object again and be done with it. Now, I just noticed when I wrote typedef, it was a color I didn't expect. And it turns out I'm using C++ for this language file. So I'll just change that. And apparently that's the color that typedef is. I didn't know. But having it on C or C++ isn't going to make much of a difference. I just like to try and keep it correct. Anyways, I can write struct object or I can write object. I prefer to just write object. I think it's a little bit less confusing to have a data type be one word instead of two. Two words seems strange. So anyway, we want a function that returns an object, and we're just going to call it create object. And as parameters to this, we're going to give it a position, we're going to give it a size, and we're going to give it a color. So all the things that an object has. And the way that we'll do this is we're going to just return an object. Now, I'm going to use a style that some people are not going to like, which is, as of, I think it was C99, you can have named member initialization, meaning I can write dot position and specify what position, and then I can say dot size, specify the size, and dot color, specify the color. So the reason to do this is if I was to change the order of these parameters like this, then this constructor would still work, or this initialization would still work. Whereas if you were to write the initializer like this, to just have the raw values, then this is dependent on position being before size. But if I change this, everything is broken. So it makes the code safer to changes. And maybe I add more parameters or more members later, and I don't need to initialize them, but I want to initialize something that comes after it. So maybe I have an int, which is called don't init. And then I have a bool which is do init. I want to be able to control that bool, and I can this way. Whereas if I had them ordered, I'd have to initialize this value. And maybe I want to leave it uninitialized for some reason. Generally, you wouldn't want to leave things uninitialized selectively. You either initialize everything or you don't. But that's just something that I think is helpful to know about. So C99, this works. Feel free to use it. It might be a GNU thing. I think ideally you would write everything to the ANSI standard, but when we're getting into these like graphical, we're starting to use graphical libraries, trying to build games, ultimately you're going to want to pick a standard and stick to it, just because writing something to every standard is really challenging, and C is generally a difficult language if you're gonna follow the highest standard. it's a very challenging language to use. But if you allow yourself to bleed the lines and use a more specific compiler, then you can get a little further. Anyway, just things to keep in mind. And it's very important as well, you know, to document your assumptions and say like, oh, this requires a specific standard. You know, especially if you plan on sharing the code to say like C99 GNU, you know, that can be helpful. Personally, I'm not going to do it, but it's something to keep in mind. Like I said, that's more of an advanced concept anyway. Okay, we're losing a lot of time here. So we can create our objects, and it would also be nice to be able to draw an object. So we'll specify an object, and we can use raylib's. Oh, now it'll give me autocomplete. Strange. We can use raylib's wonderful draw rectangle function. Now, this one needs ints, but if we look in the cheat sheet, we can actually specify position, size, and color instead of all the integers if we just put a v after the function name. So let's do that. So we can say object.position, object.size, object.color, and all we have to do is add a v, and that'll check out. Now, I don't know if the actual autocomplete will indicate that. Yeah, no, the autocomplete isn't super good. If you're working on larger projects, it's worthwhile to check out something like Code Blocks or even VS Code and you know, upgrade your setup a little bit. But for the sake of learning, I usually like to use something that it's easy for everybody to get. If you use the raylib installer, you will get this Notepad++ thing, and you can just be up and running with it. Like within 10 minutes of hearing about raylib, you can be following along. So that's the reason I'm using the Notepad. Personally, I actually use CLion, but that's not really relevant here today. So there's my draw object, and there's my create object. So we're pretty much ready to start creating objects and displaying them. So just for fun, I'm going to create an object called O, call create object, and I don't get the autocomplete that I would really like to have, so I'm going to have to keep tabbing back and forth to remind myself. So I need a position, size, and color. So I'm going to make this multi-line just because there's so many pieces of data we need here. So we need a vector 2, then we'll need another vector 2, and then we'll need a color. So we're just going to use sky blue because I really liked that from before. So position, well, you know what? Let's do pretty much exactly what we did before. So screen width by 2 minus 50. Screen height by 2 minus 50. Ooh. And then here we want 100, 100, and then sky blue. And then lastly here we'll say draw object, O, and hopefully this will just work. Oh. I see. Keep in mind when you want to press F6, you have to make sure you're in the main C file. Whatever your main file is going to be, make sure you're in that before you hit F6. Okay, we've got our object. Now this looks exactly like it did before when I just forcefully drew an object, except just draw a rectangle. But now I can do some like array stuff. So let's have a little bit of fun with an array. So we'll create an object array called objects. I'm going to make it object count in size. And we can basically, we could do this, and we could say create object like this, and you know what I mean, go down this rabbit hole, something like this, and we could explicitly create all the objects. But the truth is, I'd be happy to randomize their positions and just, you know, make it so we can see multiple objects being drawn even in a loop, just to really streamline the code a little bit. So we're actually just going to go ahead and create the array, and then in a for loop, from 0 to count, but not including count. Let's remember that. Objects at I is going to be equal to a create object, and then we're going to create a nice repeatable call here. So it'd be really nice to get like some kind of a random vector. But for now, we're just going to do something. We'll go like I times 25. I times 25, just to get like just to get kind of an effect of seeing a few different objects being kind of automatically created. So we'll make all of them 50 by 50, and I'll just make them all, we'll make them all a different color. And I think the way that I'll define these colors, I'm just going to create a color array called colors. And I picked out a list of colors that I quite like. So if I look in here, got a list of colors I quite like. They're the ones that we would have seen in that example. So I'll just add my list of colors here. 1, 2, 3, 4, 5, 6, 7, 8. Well, let's go ahead and make that how many objects there are. So we'll go colors at I. And hopefully that'll just work out for us. So we're going to create all these objects, and then I'm going to copy this because this is also how I want to draw them. So for each object, it's a little bit easier because I can just say draw object, and we can draw the object. Get rid of my hard-coded object from before. Okay, so we should get some uniqueness in the colors. Ooh, where am I going? Okay, there's all our objects. So we can create objects, set their position, give them a color. That's great. Now what we want to do is let's make it so we can get a random position, because that's not really the scattering I was picturing. And also they're pretty small. So let's get some random stuff here. So I'm going to create a new header where I'm going to put all the random code, but we're going to need some standard library stuff. So first of all, we need the standard library itself, but then we also, and that's not how you spell it, we also want to get time. So if you've never seen this before, the very simple way to explain it is there is not really a way to get true random with a computer. And I mean, there's ways you can kind of do it, and it's like whatever, or you can admit that you're lying, get fake random, but fake random still seems super random to people because the way that you kind of, from where you start counting feels very random because it's kind of incomprehensible to people. So if you can look me in the eyes and tell me you know how long a millisecond feels, you're lying to me. So if we can somehow use the number of milliseconds that have passed since some arbitrary time to drive a random generator, then that's pretty good. And it turns out that's exactly what this line of code does. So srand sets the random seed, which is kind of what I'm talking about when I say where you start counting from. And time 0 is actually going to return what I believe is the number of milliseconds since January 1st, 1970. But whatever it is, it's some number that is different every time I run this program. And so because that number is different every time I run it, then the seed that I'm using will always be different, which means I will always get different behavior. So every time I run the program, I'm going to get a different output, which is exactly what I want because I want something that's actually random. If I didn't put this line of code, later when we use the random functions, I would get the same behavior always, or potentially the same behavior always, depending on the compiler, I suppose. But generally speaking, you will get the same outputs. So this is something we have to do at the start of my program. I do this before I do anything else because I may as well. And actually, I can do all of this stuff before I open the window because this is when I open the raylib window. I can do this all before. Okay. So let's make that random.h file. Get my include guard. Me using this exact, the capitals, the underscores, it's not necessary. It is necessary to avoid dots, but pretty much I could put anything. I could put Pizza Hut there, and it would work. I'm just doing it because it's a pattern. It's familiar. It's simple. It's representative. If I define object, it's because we used the object header. If I define random, it's because we used the random header. Okay. So I really just want a couple methods here. So we're going to get a method that gives us a random vector, and in that random vector, I'm actually going to specify a min width, a min height, a max width, and a max height, just to give us a little bit of control. And then I'm also going to need a random color, which I'm going to have it pass an index, and it's not going to be random at all. I'm actually just going to say get color. Get color, I think, is actually has a name. Get color means something to somebody. So we have a list of colors, and then new color is just going to return colors at index. But I'm going to use a modulus to make sure that this never gives us an error, which is going to be color count. And we're going to define color count to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8. Yeah. So what this is going to do, this modulus operator here, and if you want to learn more about anything I'm talking about, like I said, I have the intention of creating a C course, so you can subscribe. You can also go learn about it somewhere else. There's a million places to learn about it. I just want to do my own course because I think it could be beneficial to me. So what this is going to do, really, so index could be like any number coming into this function. It could be negative 10 million to like 10 million and even more than that. It's like, I think it's 2 trillion or something is the extent of the integers. I don't remember. But the point is, it can be a wildly large set of numbers, and I only want to accept 0 to 7. Because remember, if you're not familiar with this, arrays start from index 0, not from index 1. So if my array has 8 elements, then the highest number I should allow to address the array by is 7. I should never have 8 or more. I should never have less than 0. If I do mod color count, I will never get a number equal or greater to color count, and I will never get something less than 0. So mod is a great way to guarantee that the array index you're using is safe. So when I'm passing in indices, what this is going to do is it's going to, let's say I have 8 objects, then every color will be unique. If I have 9, then 2 objects will have this color here, and the rest of the objects will have a unique color, because it'll be 1 for here, 1, 1, 1, 1, 1. So it's going to basically loop repeatedly through this array until all the objects have a color. I'm happy with this. I could also do just a straight up random number, pick a random one, but I'm guaranteed to get duplication, basically. I'm basically guaranteed to get dupes, even when the number is less than 8. At least with this solution here, if I have 8 or fewer objects, each one will have a unique color. And 8 is probably the number I'm going to use for the objects anyway. So it checks out. If I wanted more, I'd take the time to pick more colors. Which, pro tip, if you'd like to pick colors, on Google, you can just look up color picker and you can do whatever color picking you need. And if you're using raylib, your colors are R, G, B, and then alpha. So if you want to make a new color, you should make this 255 to make it a solid color. I'm using OXFF because some of them I was doing by hand, and then I realized I should use the color picker. And if you do it in the 255R, you can mix and match these, because this number is 255. So there's no mistaking that. It's just in hex. But then what you can do is, once you've chosen a color that you quite like, for some reason you want to use this color, you copy these values, and then you can paste them right in here. And it's like really easy to just paste them in and quickly generate all your colors. So that's pretty good. Alternatively, if you're actually looking to design stuff really well, you can use color mind, which is really cool. So you can just hit generate. It'll give you a random 5 colors that work well together. And if there's a couple of colors you really like, you can lock them and generate again, and you can see more. And you can actually change like the order they appear in to say like, yeah, I want this to be like an accent, and then I want 4 unique ones. Or I want like something to bridge these 2 and then 2 ones that are totally unique. And maybe I even lock this one here, and I can hit it a couple times, and I'll be able to get, so that's the exact color spacing I want. And I'll just keep going like this. I think this one's actually better. I'll lock that. Try to, oh, I didn't lock it. That's too bad. You know, and you can also type stuff in here manually. So a lot of cool things you can do with color mind and color picker. So I recommend both of those if you're trying to find some cool colors. And that's for anything. It doesn't have to be for raylib. It could be HTML or whatever you want. Okay. So that's how we get our color. For the vector, we need to do some more stuff. So there's a function called rand. We're getting this from the standard library. Woo, standard library. We're getting this from the standard library. And this is going to return a super big number, like crazy big. It could return like 3 or 5, but it's far more likely to return like millions and millions. Who knows, right? Crazy number. Not what we want. We want a number between min width and max width for the x, and we want a number between min height and max height for the y. So we want to use these things here. And the simplest way to do that is we'll write one more function here, which is called random range. You've probably used something like this before. It takes a min and a max. And the way that it works is, like I said, rand is going to give you all those crazy numbers, but the smallest number it can give you is 0. So to take advantage of that, we're going to go min plus rand. So but this is going to give us from min to whatever the max crazy number is. Let's say it's 10 million. So this is going to give us from min to 10 million plus min, because you have to think, if this is 10 million, we got to add the min on. So that's a huge range. It's not what we want. We can shrink the range a lot if we use that modulus we were talking about before. So, oops, that's the wrong one. So if I mod rand, if I do rand mod something, it's going to give me numbers between 0 and that something. So your first instinct is put max there. That's great. But the problem is now my number range is going to go from min to max plus min. It's a lot bigger than it should be. If my min is 0, it's going to turn out that this is correct. But if my min is non-zero, it's not going to work. What I need to do is I don't just want to mod with max. I want to mod with max minus min. This is going to give me numbers from 0 to max, or sorry, from min to max minus 1. We're so close. It's going to give us min to max minus 1. If we want to get that full range, we just have to add one more. And then we'll be able to get from min to max inclusive, so both numbers will be included in the random set, and we're good to go. Often, when you have a random range, you anticipate that the max will be excluded. So often, we're going to operate under the assumption that max will be exclusive to the set, and the reason is because if I want to get a random index, I can say random range 0 to the length of the array, and it'll never index into that last number, which is good because the number doesn't exist. So we want to make sure we're not doing that. So usually when you're making a random range function, it's a very good idea to make max exclusive. And if you're not going to do that, if you're going to make the int inclusive, because that is the default, if you're making int inclusive, which is against the default, you must document that, because even you might forget that it's ultimately inclusive and use the function and have an issue. So it's always good to document that kind of stuff. If you're doing something to the norm, you don't have to really document anything. If you don't understand why it's the norm, then you should document it. And like I said, if you're going against the norm, definitely document it. So anyway, that's just a little rant about documentation. It's very important. Even when you think the code is obvious, because tomorrow you might not remember. And it's that simple. For me, I'm going to remember because I'm only doing this for like an hour and then I'll never look at it again. So there's my random range. And because I've basically taken away all of the legwork of writing that function, in here I just need to say random range min width, max width, random range, min height, max height. That's it. That's how we get our random vector in our new color. So because we have that stuff, now it's super easy to create a bunch of random objects. We'll say random vector, and we'll give it a range. So we'll say 100 to screen width minus 100, and 100 to screen height minus 100. So that's the position. So no object can ever be within 100 of the border of the screen. And then we're going to say random vector. Now we need the size. So the size, I'm not quite as picky. So we'll say 150 to 300, and we'll do that for both X and Y. And then with the color, we're going to get a new color. And we're going to pass I, just to kind of ultimately drive that array that's down below. Okay, so we're assigning the value of object at I to create object, which is going to give us a random object, random position, random size, random color. And now we're also going to draw them in the loop as we were doing before. I don't have to change that. Okay, let's run this. Okay, I don't see any colors. I'm assuming the problem is that the colors aren't loading properly. Let's see if we had any warnings or anything. Value computed is not used. Look at this. Forgot to return. That's good. Of course, it's a function. It's supposed to return a value. If I don't use the return keyword, it doesn't return anything. And even worse, it doesn't look like it worked. Huh. Oh, I see. I believe that it's refusing to compile the file because the actual main.c hasn't changed. So what I have to do is delete the main.exe so that this thing can see that there is no thing to compile. And no, that's not it. Okay, hang on. Let's think for a second here. Okay, looks like we're having an unrelated issue. So let's investigate. So create an object. Let's do that. I don't think, hold on, let me just make sure that that's not why. No, okay. From I, looks like there was a issue there, but I don't think that's the problem. Min width, max height, max min, rand, standard library, color colors, 1, 2, 3, 4, 5, 6, 7, 8, Okay, I'm a little suspicious. Maybe this does need to come after the init window. Okay. I'm not sure why. I'll be honest. Let's try. No, now it's just doing it. Okay, I think maybe it really just needed to see a change to the C file. That is truly mind-boggling because I don't see any object file outputs here. I'm really not sure. I'm really not sure what went wrong there. That's upsetting. Sometimes some functions need to come after init window. So for instance, if you're loading textures, then that needs to happen after init window because init window is going to create the graphics context. And to load a texture, you're really loading that texture to the GPU. So you really need to make sure that the window's already been initialized. Otherwise, it's not going to work. And it won't give you any kind of errors. That's the most upsetting thing. If it does give you an error, it won't be at compile time. So it's really what I mean. Anyway, just something to keep an eye out for. Okay, so now we've got the objects spawning and they're ending up in random positions. So if I just open this and I run this, so you can see they're kind of all in the middle to the right. Now there's some on the left and a little higher. But yeah, we're missing out on that whole first 100. So maybe I should reduce that a little bit to like, make this one smaller because, and then make this part like higher because what's happening is, it's able to create the object, and the corner, the top left corner of the object is the origin, right? So for that reason, and we explored that at the very beginning. So for that reason, if I say don't do it between 0 and 100, then all of the things are always going to feel like they're kind of in the middle. And because we're excluding the fact that since at the top left corner is the beginning of it, we can actually give a much smaller margin. And something else we can do to make this work a little bit better is I can actually get a vector2 called size, capture the random size that it chooses, just write this in, and then here I can say size.x and size.y, and we can just then add our 10. So we can say that the padding should always be 10 pixels, but we can do it more dynamically like that. And then the distribution will look a little nicer, yeah. So we can get them much closer to the edge of the screen like that. So see, I see the colors, I see the distribution, the sizes. I'm already trying to click and drag these, but we haven't set that up yet. So the way that we're going to do that is we're going to have some information here that tracks kind of what's happening. So the first thing I'm going to do is I'm going to have an int which is called dragged object index, which is starting off at -1. We're going to have a vector2 called, we don't need that actually. We just need a dragged object index. So this in here, we only want to put draw stuff. So if I want to have update code that's called every frame, I really want to put that here. This is my update area. So in here, what we want to do is in raylib, we have this function is mouse button pressed. So there's down, pressed, released, and up. Is mouse button up means is it not pressed at all? So it's not being held or anything like that. It's totally up. You can also get that by saying not is down because they are the same thing. In fact, I wouldn't be surprised to say that is mouse button up might even just be not is down, because is mouse button up I think is newer. Pressed is true the frame that the press begins. So if I click and hold, pressed will be called once, down will be called continuously as long as I'm holding, and then released will be called once when I release. So I want to do pressed. I want to find out if we're pressing it right this frame. And what you'll find is it takes a int button, and that is going to be mouse button, and then you will put left, middle, or right. And this is actually a constant that ultimately becomes 0, 1, or 2, I would assume. So you could also put 0 here, but for readability, we're going to use the mouse button left thing, which, by the way, if you're not sure, you might think like the raylib cheat sheet is not the end-all be-all. It doesn't have all the information. If you want to know the most you can about raylib, I would say open up the header file, and you can actually control F anything in here. So you can see, you can see here mouse button left, right, middle, side, extra, forward, back. So there's the enums, and there's a lot more stuff. Mouse cursor, you can change what cursor to show, all that kind of stuff. Very cool. So it's worth a read, but it's very complicated. So it's more like you kind of want to keep it open as you're learning, and you can keep going back to it to learn more. So if the mouse button is being pressed on this frame, then in that case, what I really want to do is I want to have the same loop as before. I want to go through every object, and I want to see if my mouse cursor is within the bounds of that object. So we have a check collision point rec, which checks collision between a point and a rectangle, or in other words, check if the point is inside that rectangle. The point is get mouse position. The rectangle is, we have to define a rectangle that defines the shape of the actual object itself. So what I really want to do is put M position here, because mouse position, I want to like save that as a variable, because mouse position won't be changing within the span of one frame. It can't. So we can store it before I do this whole loop. Otherwise, I'm calling it every frame, and I'm not sure, like, I don't know if that's a complicated function or not. Maybe it's actually polling the input devices and doing some math. I don't want to do that repeatedly. So for the sake of just being on the safe side, I'm going to store it in a variable. And the reason that's safe is because I know it's not changing over the duration of this loop. If it was something that was always changing, maybe I'd want to do that. And the other thing I want to make is for each object, so this one I have to do within the loop, for each object, I want to make a rectangle. We'll just call it objr for object rectangle. And we're going to break it out like this. So it needs an x, a y, a width, and a height. So the x, y, width, and height are all within the object, but they have like layers of abstraction, which what I mean is we have to like peel back some information to be able to get those. And since they're in an array called objects, for each thing, I'd have to write objects at I dot position dot x, and that's a little bit awful. So just to make it a little bit easier on us, we're also going to get an object called obj, which is objects at I dot position. Oops, not position, objects at I. So I can write obj dot position x, which is still not great, but it is shorter. These two, I want to write size instead. And then I want to change this one and this one to y. So the rectangle, and we can learn more about the rectangle as well. If we go to the cheat sheet and go to the bottom, struct rectangle is a rectangle type. If I want to see precisely how that works, I can open raylib. I can search for a rectangle. So you can see it as an X, which is the top left corner for the Y, and then the rectangle width and height. So it's pretty simple. I think actually when you write rectangle R is equal to rectangle, maybe we'll get a breakdown here. No. Well, it's pretty simple anyway. Nothing to worry about. So I'm saving the object, a copy of it that is. Then I'm doing all this. Because I'm copying the object here, if I change OBJ, it won't actually change the object. So I have to remember that. So if my mouse is inside of this rectangle, on the frame that I pressed, then I want to say that this is the one that I'm grabbing. So I have this variable way up here, dragged object index, which is going to be given to me by I. So I'm going to say dragged object index is equal to I, and then I'm going to say break. I'm actually going to break, which means I'm going to skip the rest of this loop. If I don't do this, what I want to do is I'm going from 0 to object count, and I'm going to imagine that 0 is like the top of the list. So if I click on that top thing, that's the one I want to grab, not the ones behind it. And if I let it loop forever, it's going to keep changing that dragged object index to the ones that are behind it if they're all overlapping. So that'll create an issue for me. So I want to set the dragged object index to I and break. Now, later, what I want to do is if my dragged object index is not -1. -1 is like my I'm not grabbing anything. So if my dragged object index is not -1, then objects at dragged object index dot position. So now I'm not accessing it as a copy, so this will work. I'm going right into the array and changing it. I'm saying that position is going to be equal to get mouse position because it's being dragged. So it should move with my mouse. And something else I want to keep in mind is if at any point the mouse button is released, then the dragged object index should be set back to -1. Like if I let go of the mouse at any point, I want to make sure we're actually letting go of it. So let's just recap that real quick. So I save the mouse position, and if we press the mouse left button, then I'm going to go through this loop. Oh, I saved it, so I should use that here. If I've pressed the button, we're going to loop through all the objects and see if I clicked on any of them. And if I did, I'm going to save that index and keep it to the side. Now, when I release the button, I'm going to unset that index. But if the index is not -1, I'm actually going to move the object at that index. So hopefully that is that's just fine, right? Let's give it a shot. F6. Ooh, F6. There we go. Okay, moment of truth. Oh, okay. Weird. So when I grab it, it snaps to the corner. And it's not grabbing the one I expect. Like I expect it to grab this green one, but it's grabbing random ones, it feels like. Well, I didn't even know there was a blue one there. That was exciting. So what's going on here? So the center of the square is here, but the beginning of the square is up in the corner. So when I click here, it's going to snap that corner to my mouse, which is not really what I want. And I thought I was going to grab the top ones, but no. Well, here's the thing. If I start grabbing them and layering them like this, we're going to notice something pretty quickly here. There we go. Now they're in order. If I try and grab this one here, it's going to grab the back one. Because when we draw from 0. And when we pick from 0. So we need to make a choice. 0 is either going to be the top or the bottom. Right now, 0 is the bottom, but I would like it to be the top. And the easiest way to change that is when I draw the objects, I should start from the top, object count -1, and go as long as I is greater than -1. Instead of moving I up, I'm going to move I down. That's the simplest way to change it. So now when I grab something, I will always grab the one that's on the top. So it looks like this one is definitely above this one's behind it. So I can do the same sorting game that I did before. Wow, that was insanely lucky that I always grabbed the lower one. So now if I grab here, it'll always grab the one that I expect it to. But it's still doing that weird snapping. So the reason that's happening is because I'm setting the position directly to the mouse position. But remember, that position value represents the top left corner. Do I want it to represent the center? Sure, let's try that. So instead of setting it to mouse position, I want to set it to mouse position, but I want to take out half of the X size and half of the Y size. So we need to do this in 2 steps. First, position.x is equal to mouse position minus objects dragged object index size x by 2. Kind of a long statement, but get the mouse position, and then this object, its size, its width by 2. So that's kind of what we were doing before. We were subtracting half of the width. And I'm going to do the same thing, but for y. So I'll change this to y, change this to y. Okay? Let's F6 that and see what we get. May have made a mistake here. Dot position dot x. Mouse position is a vector, so we want to only use the x and y components here. That makes sense. Okay, it's better, but it's still jumping. It's jumping, right? Because the center isn't necessarily where I'm grabbing it. You know? Let's see. This is a fun little game I've made here where I'm sorting these. So if I click near the center, it looks pretty good, but if I click near the corners, it looks really bad. So how do we fix this? Well, instead of using the center, what I want to do is when I click down, you know, this is the corner, this is the center. Forget the center. This is the corner. This is where I'm clicking. I want to store the line from the corner to my mouse. I want to store that so that every frame, instead of moving my square to the mouse's position, or instead of moving the center of my square to the mouse, I want to move that part of the square to my mouse. And the easiest way to move that part of the square to my mouse is to move my square to that distance from the mouse. So if my mouse cursor is starting off right here, I'll use the corner of this notepad as an example. If this corner of the notepad is my cursor, I want to save this line so that every frame, instead of setting the position to the cursor, I set it to the cursor plus that line so that it offsets the corner where I want it to go. That's what I want to do. So that'll be really easy, actually. So we're going to get a new vector. We'll call it M offset for mouse offset. And I'm just going to set it to the 0 vector just for safety purposes. It's always a good idea when you're creating variables like this, especially in the global scope, meaning it's outside of the main function, to give it a value right off the bat. Because it might be the case that I make other files use those. That's why I'm making them global, so that everybody can access them. And depending on how everything shakes out, those variables might not get set by something else, and they could have something in it that I don't expect, maybe something dangerous. So it's a good idea to give it a default value. Some programming languages always initialize stuff to a default value. In C, that is not the case. So in here, if this code executes inside this if statement, we are grabbing something. So at the moment that I grab something, I'm going to set mouse offset equal to, and now I got to do some math. And I'm not going to do the math myself. I'm going to cheat. I'm going to use raymath, which is something that a lot of people forget about. So if we go into source, there's a bunch of header files in here that Ray has included for us. And one of them is raymath. There's another one, really good one, called easings. As you become more familiar with programming with raylib, I highly recommend you dive into this one. It is amazing. And I'll be having a whole video about this for sure when I do my raylib series. So raymath, we'll open this one up. It's got a bunch of cool functions. I'm going to look up vector just to give you an idea. Let's see if we can get to the stuff I like here. You can see it defines the vector 2 just in case it's not already defined, but of course we're using raylib, so we have it. Here we go. So vector 2, 0, vector 2, 1. Okay, those are weird. If you don't know much about vectors and math, you might not know why this is special. But this right here, look, it's vector 2, 0, 0. That's exactly what I've written here. I can't use the function here because it needs to be a constant value when you assign out here. If I put a function there, it would give me an error, but that's fine. 1 is like an identity, so you can use that as like the standard for a small vector, perhaps. And this is entirely up to you. But here's the really good ones. Vector 2 add, vector 2 subtract. Those are the ones we need. So you give it 2 vectors, v1 and v2, and it'll return v1 minus v2. And if you don't know about vector math, it's this simple. The x of one minus the x of the other, the y of one minus the y of the other. It's really, really simple. We'll see. I mean, I don't know how deep I'll go with the tutorials on this page. Maybe I'll create a bunch of like basic vectors, high school stuff too. I don't know. We'll see. A lot of us took that class, but you might not remember it by the time you get to coding. You know what I mean? Cool. So at the moment that we click, we want to set that M offset to something. We're going to use vector to subtract. So if you put two vectors in subtract, the graphical implication of it is that it's like drawing a line from one point to the other. So if I give it a point A and a point B, and I want to get a line going from A to B, I go B minus A. And if I want a point to go from B to A, I go A minus B. So if you want to start one place and go another, you give the starting one as the second part of the minus. So I want the line to go from the mouse to the corner. So I'm going to go corner minus mouse, meaning I have to say object dot position, then mouse position. And that's my mouse offset. And now when I'm setting this value here, I can actually do this a lot easier now that I have ray math. I want to set this position equal to vector to add mouse position, mouse offset. How easy that is? Okay, now let's run this. There's a chance that I got it backwards and the box looks a little funny. No, looks good. I'll show you what I mean by if I got it backwards and the mouse looked funny. If I got these two things mixed up. So if I do mouse position minus object position, it'll look pretty funny. So you can see if I'm really close to this thing, it's pretty accurate. But if I go to the corner, it's way off. But you can kind of see, like, you can almost, so if I do this one here, you can see that that rectangle would fit between my mouse and the rectangle. So you can see I'm pretty close. I just got it backwards. So if you get something weird like this, try flipping these. Okay, this is looking pretty good. We're getting really close. Something I'm gonna add is that little shadow. I really liked how the shadow looked when I had it in the example project. So I'm gonna get that shadow in here, and then we will move on to actually the last step, which is gonna be getting the stacking to work correctly, because really when I click on this, I want it to come to the front. And once I add the shadow, we're gonna see why we really wanna do that. So let's add the shadow. So basically when we draw the object, I gotta do a little bit of if here. Like I said, don't put a lot of math in here, but you're gonna have a couple if statements probably. But keep it to a minimum. Like, so all this stuff here where I'm looping through all the objects, checking collisions, that is very much, don't put that in the draw loop. But when it comes to, you know, I want to draw some objects differently based on how they are. And for that reason, I have to do a little if statement. So if the dragged object index is the index that we're actually drawing right now, then I'm going to draw the object. But instead of saying draw object, I'm going to say draw object shadow. And then I'm going to create a vector to, you know what, actually, I will just make these like this. There we go. So I need to make a couple new functions here, draw object shadow and draw object offset. There we go. Okay. So when we draw the object shadow, we want to do almost the exact same thing as the regular draw object, except I want to use a faded black to about 75%. And when I draw the object offset, again, I want to do almost the exact same thing, but instead of using object position, I want to make a new vector 2 called position, which is object position, but we're going to subtract a value. So subtract value will take a certain number away from X and Y. So we're going to need ray math here. And I'm also going to define shadow pop to be 16 pixels. So it's not the same as subtracting a vector, because subtracting a vector is much more complicated because you have a different number coming out of X and Y. But if I want the same number to come out of X and Y, I can use subtract value instead. Now we're going to subtract them to give them a shadow pop. So remember, the corner is on the top left. So if I subtract from each, it's going to move it, like subtracting from X will move it left, and subtracting from Y will move it up. So it's going to give us, it's going to make it look like the object has physically risen and that there's a shadow below it that normally we can't see because presumably the object is blocking it. You'll see. It creates a pretty neat effect. So you can see now it looks like I'm really picking these things up. The only thing that sucks about the illusion, so see if it's the top one, it looks awesome. That looks awesome. When it's one that's below, the illusion really fails. So the last step is going to be to get that structure working. So I'm going to call this a stack because physically the objects, the position of them in the index corresponds to their position in the world. However, a stack is actually a very different kind of data structure that I'm going to explain at a later time. But for the purposes of this video, we're going to make our own little fake stack. This will be our last header file. So all that we really need to do with a stack is we're going to have an object array called objects, and the size is going to be object count, and that's really all there is to it. The trick is we have a void method called move object to top, or even let's say move index to top, and it's going to take an int index. And how this is going to work, if we can imagine our list, right? So let's say when we talk about the list, the indices are like this, but the contents are maybe something like this. So it has the elements, it has 8 elements, and the contents are like what's in these brackets here. I'm pretend that that's like a special object. The reason I put it in curly braces is so that you're not confused and think it refers to the index. So if I try to pick up number 7, I want to move 7 to the top. So the way that I do that is I take 7 and I copy it into its own spot. So 7 has its own little space now. Now I'm going to take what's in the element above it and copy it down and keep doing that until I've done that to the second last element. Then I will take the one I saved and put it there. And that's how I'll move things to the top. And what you'll notice is I took one thing out, let everything else fall to fill the gap, and then placed it back to the top. So imagine you have like sand blocks in Minecraft. That's the only way I can think about it. Pull it out, stick it on top. The tricky part is simulating gravity, actually pulling the objects down. And when I say tricky, it's fairly simple. But the reason it's tricky is because if you screw it up, you get a really scary looking error. But don't worry, I'm going to do it, and you'll see how. So if I want to remove that index and I want to move it to the top, it's really simple. So first, I'm going to get an object which I'm going to call copy. Now I'm going to go to, I'm actually going to set that value, equal to, oh, and don't forget, we got to provide the stack here. Now I got to make it a pointer because I'm actually changing the stack. I'm making a change to the stack object. If that doesn't make sense, if you're not familiar with it, pointers are a little bit tricky, so it could take a while to learn. I'm not going to cover it right now. We're pretty late in this tutorial. So stack objects at index. I'm going to copy that object out. Now in my for loop, I'm going to start from index, and as long as we're greater than 0, we're going to move I down. So we're moving left in the array, or like I said, I'm treating it as a stack where 0 is the top. So I'm going to move up in the array. But starting from the place that I just created that hole, I'm going to set stack.objects at I equal to stack.objects at I minus 1. Now, this is safe to do because I'm not allowing I to be 0. I must be greater than 0, which means I minus 1 will always be an array index. So long as I is an array index, then I minus 1 will be an array index. And since I'm starting from index, which is given to me, I'm assuming this is valid. If we pass an invalid index here, everything will break. So just keep that in mind. You can make it safe if you want by setting index equal to itself modded with object count. If you send a valid index, this will do nothing. But if you send an invalid index, it'll at least make it safe. But it will also lead to some confusing behavior. So what you really want to do, if you're trying to make this really easy to debug, is you say if index is greater than or equal to object count, or index is less than 0, and then maybe you're going to want to, like, you know, printf or an error logger, something like this, you know, basically say like, oh, there's been an error. Maybe you'll create a file and write it in the file. I don't know. It's up to you. But you might want to log that. Now, for me, the way I'm going to set it up, that's not going to be a problem. But when you're working on larger projects, it's a good idea to, it's called an assertion, basically, to write an if statement that you know will never fail, so that if it ever does fail, you know exactly where it is. Whereas if you write 1,000 lines of code over the span of a few days because you're really cracking down on this project, and then you hit play and nothing works, like, what are you supposed to do, right? You don't even know where to start debugging. And debugging, like, there are debuggers out there that let you actually, you know, you can actually choose a point in the code and say, you know what, when you execute, stop right here. This is like, that's what this is. And that's great, but you have to know where to set the breakpoints, which means you kind of already have to know where the problem is. So it's a slow process. If you can do those assertions, your debugging will take 20 minutes. So it's a good idea. But for the purposes of this, it's out of scope, but it's worth mentioning. Anyway, for each element, we're going to do that little cascading thing that I showed you. I thought I saw the note, but I guess not. And then when all is said and done, stack.objects at 0 is going to be set to that copied value that I saved from the beginning. Now, with pointers, it's tricky, so I forget this often, but we can't say dot on a pointer. We have to do this little arrow. So that's just a little thing I forgot to do. The only reason we do that is because it's a pointer. If it was not a pointer, we would just say dot, but because it's a pointer, we have to put a little arrow. It is what it is. Okay, so this is going to move whatever's at that certain index up to the top. Great. So let's go to main. And when we do this, we're going to say, move index to top. We're going to pass in a stack, which we're going to need to make, and that I value. Now, here I'm saying dragged object index is equal to I. Since we're going to make it so that when we click on something, it moves to the top of the array, we actually don't need this anymore. So instead, what we want to say is dragging and set it to true. And in here, we just say is dragging. Here we set is dragging to false. And we change this to bool is dragging, which starts off as false. So set is dragging to true, move this index to the top. So this stack, we just need to create that. So over here, we're going to create a stack called stack. I'm going to make it a pointer. Yeah, let's create a stack called stack, which is, I'm just going to do this, which means all of the values are going to have like a default thing of their own. And then instead of writing stack here, I just need to put an ampersand. I wanted to make it a pointer, but you know, not much easy ways to do that. So there's stack. And then anywhere we say objects, all I have to do is add stack dot to the beginning. Do it here. Stack objects, dragged object index. So here we just put 0. Because the thing at the top is always going to be the thing. And then here we just say if is dragging and I equals 0. Then we do this. So this is almost never going to Like is dragging will be false and it'll skip, or I is not 0 to be false. There's a really cool optimization here we can do. It's a really simple thing, and it will make a very small difference, but it will make a difference if we had 1,000,000 objects. I'll talk about it in my epilogue here, but we're almost finished. So let's see if we can get this to work here. Okay. Draw object shadow. Object at I. Right. Alternatively, something you can do, something you can always do is create. So you have stack, and this is something I should have thought about, is create an object pointer called objects and set it equal to stack.objects. That's something you can do as well, but I didn't think about it. It wouldn't be an optimization. It's just like it would require less copy pasting, basically. Okay, looks pretty good. So now we can change the order of things. I can click on random things, pop them to the top. If I just click, their position doesn't change, which is kind of what I wanted. So we can really play around with this. So now with a setup like this, now all you have to do is build an actual game, but at least the system of creating these floating objects is actually, it's literally just, it's built in. So having these objects do something, that's up to you, but now the actual drawing and management of the stack is automated. So let's just talk about some of the optimizations that I was just thinking about. So the first thing is, in C, there was a concept of a, I don't know, in school they called it a short circuit. I really don't think that's a good name for it. But the idea is when you have Boolean expressions that have an and or an or, there are certain times when you don't have to finish the evaluation because it's multiple pieces. So in an and, if the first thing fails, you don't have to check anything else because and requires everything to be true. Now, I is only going to be 0 once per loop. So if I put this first, oops. If I put that first, then is dragging will be checked fewer times. But checking I is 0 takes, like, it could take longer to compute whether or not I is equal to 0. Now, in truth, I equals 0 is actually a fairly easy thing to check, specifically because it's 0. If it was any other number, it would be fairly difficult to do this. Alternatively, something that you can do is basically handle the 0 case outside of the loop and then do everything else normally. But I think checking if I is 0 is probably your best bet. And then is dragging. So sometimes the order of these things will actually make a difference. And in the case of or, if the first thing is true, it's not going to do the rest. This is good and bad, because what if this is a function that does something and then returns true or false or whatever? Well, in the case of an and, if this fails, I won't call that function, which is really great if I only want that function to happen on I equals 0, but that's really confusing. And somebody else might not know that. And it's very error prone to do stuff like that. So typically having a Boolean in an if statement as a part of an expression, multiple Boolean expressions, that's a bad idea, okay? Like, it just doesn't make sense. It's so cool. It looks so good. Just like having an if statement with no brackets. Over here, I could do this on both of these. Oh, that looks so cool. But it's not the greatest thing. It's a little bit error prone. Because if I decide I want to add a function later, if I want to write here, you know, do Pizza Hut, then I need to now add brackets, which is annoying. And if I forget, then this is always going to happen. It's really going to be this, and it'll always happen. It's a little bit not good because it's not clear what's happening. When you write code, you want to write code that is 100% clear to a human reader and 100% clear to the computer. And if you get anything less than that, you got to start using comments. And the more comments you use, the more you got to ask yourself, am I doing this right? Because if I have to comment everything, maybe I'm doing it wrong. So it's a little harsh, but it's worth thinking about. Some improvements I would make here. I would move this stack out to the global scope, and I could simplify this whole program visually. So we will try that now. So I'm going to create two void methods, one called update and one called draw. Jump to the bottom of the file, create an update method. Function, excuse me. Create a function called draw. Everything that's in the draw, I'll just say draw and do all of this. In fact, I actually usually like to do this. Just kind of showing you how I like to structure my raylib projects a little bit. So there's my draw function. And then for update, same deal. So I'll cut out these update comments because I don't really need them. Cut all of this. Run update. Place it in there. And then actually, I don't think I need to move it to the global so much. I can actually just pass it through here. And then okay, update the stack, put stack in here, has an ampersand. And then lastly, this is all the init stuff. So I can cut all of this and I can put all this in initialization, but then I would have to move this to like some kind of heap. But I could easily, or move this to like the global scope. But I could easily put this like this, cut all of this, write init, and we'll write one more void function here. By the way, it's good practice to, when a function is void, void parameters, to actually write void in the parentheses here. There we go. We want to put the stack pointer here as well. So in init, we go through all the objects, initialize the stack objects, make this stack. Okay, let's see if I pulled it off. Ah, almost. I see. I need the stack in all of these. But this one can be like a read-only stack because I'm just drawing. So you see, because I have to pass the stack through to everything, that's usually a good reason to make something global. But at the same time, it's not much of a hassle. But if I had six or seven things, you know, like having these global is really helpful. So pick and choose your battles. Ideally, nothing would be global, but ideally you would probably not use C. And I don't believe in that. I think if you do some things that are usually frowned upon, C becomes very viable, as long as you're very careful and you always validate your assumptions. So here we are. We've arrived at our little thing. It did take an hour and a half, but we did also take a lot of stops along the way to explain some concepts and to try a couple things. If I did this, you know, because I do know everything that it takes to build this example, I've done it more than once. If I had gone as fast as I could, maybe I could have had this in 20 minutes. And that's giving time for bugs and all that jazz. So now you can take this code. It's going to be available for sure. I'll make it, I'll share it because I have no reason to hang on to it. You know, this can be shared. If you want to download raylib, I'll leave a link to the raylib website in the description. And everything else, you know, everything else is here. So you could just download this, load it up in Notepad++, and take a spin on it. I've had fun. Hopefully this was interesting, entertaining, something. If you're interested in learning more about raylib, there is a fair amount of resources out there, including Ray's own resources on his page. So if we actually go to the wiki on his GitHub, he's got information about how the library is ultimately designed, if you're curious. He's got stuff about how the syntax in raylib works. You know, how he named a lot of the functions and why he chose that naming, and you know, actually good mnemonics to like sort of memorize things. You can learn if you read this. You'll figure out like, oh, I don't remember what the function is called, but I know what it does. So I can ultimately synthesize the name based on these rules. And there's a lot more stuff here. You can read about the different data structures that are provided in raylib. Raylib does support 3D. So there you go. You can do meshes, shaders, materials. You can build a full on game in raylib in 3D. I haven't experimented with it much because it's very complicated. 3D is a lot more complicated than 2D. And I think if I was going to build something in 3D, I would probably end up switching to Unity or even Monogame with C#. Because if I'm building something in 3D, I'm going to want to make use of object-oriented features. But that's one more thing I want to say about raylib. Raylib is built in C for C99, which means it works on everything. So if you look on the side here, Windows, Mac OS, Linux, Chrome OS, Raspberry Pi, of course, which, you know, FreeBSD, GNU Linux, Raspberry Pi, Android, like those are all very related. Even web, you can even get web deployment in raylib working, and it's pretty good. I'll say I've used it a handful of times and I really love it. And aside from all of that, as if that wasn't enough, if you scroll down on the raylib front page, you'll see that raylib has bindings to multiple languages, apparently more than 50. So if we go to more and we look, here's a list of all the ones that he officially recognizes, which if you were to create a binding of raylib to something, he would be more than happy to put it on here. You just have to ask. So everything, raylib, C#. I'm not sure what the low version is, but I know it's something. And look at this. Like, there's so many languages here I don't even know. I mean, of course, there's ones that everyone knows, like Lua. There's actually more than one Lua binding. Looks like there's 3. JLib, which is Java. I do not recommend using raylib in Java, but that's because I don't recommend using Java. So feel free to do that. And it's very interesting. Obviously, the syntax changes a little bit, but you know, that's something. And then here's the thing, right? Raylib CPP, you can see here there is even a binding to CPP, which obviously C++ is a very popular programming language, and you can use these really cool, you know, it puts it in a namespace and adds some like utility methods like get width, you know, member functions and things like this. But what I think is the most impressive thing about raylib is for me to take this whole project that I just built, copy paste it, and say CPP, and then for me to open this folder, let's go open. Let's open these files. For me to take this project right now, go into F6 and change this to G++, and then hit OK. This is now a C++ program. I'm running this in C++. I didn't have to download a new version of raylib. I didn't have to change any of my settings. I just changed what compiler I use. And now I can go in here, change this to C++, and I can pull in algorithm and functional, and I could probably write aha. Okay, that took a while, but here we are. So that took maybe 5 or 6 minutes, but the point is I didn't have to download anything. I didn't have to use any other resources. It was all in my own Lotion. So that's just something to keep in mind, that raylib will work right out of the box with C++. If you're doing a lot of dev, maybe it's worthwhile to check out one of those C++ bindings, but this way you can always be up to date. That's the only downside with the bindings, is that if the creator of the binding kind of goes off and about, maybe they go on vacation or something, or they're just not really interested in maintaining it anymore, and nobody's interested in taking their place, then you'll be forced to either use an old version of raylib, which is okay because it's not often that huge features come out these days, more like just small tweaks, or you'll be forced to actually update the binding yourself. So anyway, that's a lot of chitter chatter. Thank you so much for watching. Be sure to check out the page. Maybe give me a month, but I'm going to start posting tutorials and content here, and it'll usually be shorter form than what we have here today. This is very casual. I just sort of let it run while I experimented, and especially with the ending there. So thank you so much. Once again, the source code is available, and I'll probably get a web build running as well. Okay, thanks so much.